transform. Is Fourier transform. So throughout this chapter, we are supposed to discuss three transformations. Three transforms. Those are Fourier cosine transform, Fourier sine transform, Fourier transform. So before moving to the Fourier transform, let's discuss Fourier cosine and sine transform first. So in our previous chapter, we have discussed about the Fourier series. Can you remember the Fourier series? So Fourier series, what is Fourier series? Fourier series is an infinite series representation of a function which involved with some trigonometric terms. So that means we have a function and we are starting from that, obtaining a infinite series expansion of this function, that respective function in terms of sine and cosine terms. So now starting from that term, it is a series. So now we are using a new word, Fourier transform. So we have learned the Laplace transform earlier. So what is the meaning of transform? As we discussed earlier, transform means we are converting something into some other thing. So here also we are going to do the same thing. So we are starting from some function and we are obtaining totally new function starting from that given function. So here, as we have mentioned that the meaning of the integral transformation is we are obtaining a new function starting from a known function by using some rule, and we are obtaining a completely new function, capital F of S. To obtain that one, we are using an operation which is involved with integration. So in the definition of the Laplace transform, we have discussed that thing. And here, we are going to proceed with the same thing. This is the new transformation method. We call it as a Fourier transform. It is also an integral transformation method. That means we are starting from some function and we are obtaining a completely new function starting by using an operation which related to some integration. Can you remember the way of obtaining the Laplace transform f of s? The rule. Can you remember the rule? What is the integration that we have considered? We are considering from 0 to infinity e to the power at f of t dt. So by e to the power st. So by starting from, by applying the respective function f of t here, we have obtained this f of s. So that is the rule that we have learned in the Laplace transform. So now we are going to discuss Fourier transform and what is the rule and how to apply this transform techniques. So those are the things that we are planning to discuss under this chapter. So let's see. First, as I mentioned earlier, before moving to the Fourier transform, first we are going to discuss about the Fourier sine and cosine transform. Can you remember? Can you recall when we are discussing about the Fourier series? I am asking about Fourier series. That means the last chapter. In the Fourier series, we have defined odd and even functions. Odd and even functions. So if it is an even function, then what is the important concept when we are obtaining the Fourier series of that even function? If it is an even function, a naught a n b n. Can you remember? If it is an even function, the sign term bn equals to 0. So if we have a original function f of t is an even function, then we will obtain a infinite series which only consists of cosine terms. So we call that as Fourier cosine series. No? So when we are considering odd function and when we are obtaining the respective Fourier series for the odd function, we can see that a0 and an both terms are equals to 0. So then when we are considering an odd function, the resultant Fourier series which only consists of sine terms. So we can say that it is a Fourier sine series. So we have discussed those things in the previous session. So now we are going to consider by starting from that Fourier sine series and Fourier cosine series. Now we are going to obtain the Fourier cosine transform and Fourier sine transform. So let's see. Now this is a brief introduction. So actually, as I mentioned earlier, Fourier transform is also a integral transformation method. That means we are starting from one function and obtaining a completely new function by using the operation related to the integration. And then when we have learned in the Laplace transform, we have used the Laplace transform to solve ordinary differential equations. So similarly, this Fourier transform, we can use this Fourier transform to solve ordinary differential equation. Not only ordinary differential equation, we can use this to solve partial differential equation. So in your next chapter, we are going to learn about partial differential equations and how to use this Fourier transform to solve the partial equations. Okay. Cosine transform. Okay. මොකද්ද ප්‍රවීෂ් කියන්නේ නංගිගෙන් අහගන්න පුළුවන් එයාට න Okay, so Fourier cosine transform. What pin? So as we mentioned in the Fourier cosine series, so we can obtain the Fourier cosine series for even functions. Similarly, here we are going to obtain this Fourier cosine transform for even function. To write down this expression. මේක ආවේ කොහොමද කියලා හිතන්න එපා. ඒකෙන් තමයි ඊළඟට හිතන්න. So this is the we are obtaining the expression for Fourier cosine integral, not about the Fourier cosine transform. This is we are starting from Fourier cosine series, and by starting from that Fourier cosine series, we are obtaining something new which we called as Fourier cosine integral. So once we have obtained this Fourier cosine integral, starting from that Fourier cosine integral, in the expression for Fourier cosine transform. So don't worry, don't think about how do we obtain this one. That is not need for you. So but by I just add this here because we are going to obtain the Fourier expression for the Fourier cosine transform starting from this one. So this is the expression that we have obtained starting from the Fourier cosine series. So we call this expression as Fourier cosine integral. So there are unknown variable here. That is why I mentioned that you don't need to worry about this thing. So okay, the notation and use this notation. This is something that you need to familiar. We use this f hat c w. So in the Laplace transform, if we starting from function f of t and then we apply the Laplace transform, we will obtain a function capital F of s. Similarly, in the Fourier cosine transform, if we starting from the function f of x, by applying the Fourier cosine transform, we will obtain a function f hat c w. Here, in case, this s is the variable. In the Laplace transform, the resultant function. Here the variable is w, and then this c represents the cosine. So we are using this notation f hat cw to represent the Fourier cosine transform of the function f of x. So that is the notation. So let's move on. So in this slide, the important thing that we need to familiar with this notation. Don't go through with the remaining thing, and this is important because we are obtaining this cosine transform for even functions. So this is the expression. Straight is the expression. So in this expression, here we have obtained an expression for this AW, the function of W, and by replacing this replacing this new by variable x, we will get an expression for Fourier cosine transform. And if you are asking to find the Fourier cosine transform, you need to follow up with this formula. This notation is for Fourier cosine transform of the So this notation is for to represent the Fourier cosine transform, and if you are asking to find the Fourier cosine transform of some respective function, we are going to consider this integration. This is the rule to obtain the Fourier cosine transform. We are going to consider the square root of 2 over 5 integration from 0 to infinity f of x cos wx dx. The integration is not much something complicated. If you have if you are unable to apply the partial integration by parts, then you will not be able to obtain the answer. So here, if we have asking to find the Fourier cosine transform of f of x is equal to something, is x squared. So then you need to replace this f of x by that respective function and evaluate the integration and obtain the answer. So the answer may be consist of the w terms. Answer may be consist of some w terms, and if you have asked him to find the respective function f of x when the Fourier cosine transform is given, that means the formula to find inverse Fourier cosine transform is the second formula, the formula which labeled as number 2 for the so this is the expression for Fourier cosine transform, and this is the expression for inverse Fourier cosine transform. And then by obtaining this f hat c, which is starting from this f of x, we call this process as function So that means we are starting from f, and we are obtaining this f. So that means step process. That process.
You are muted.
I hope you don't have.
You are seeing
Me have no doubt. And at least note down these two formulas. The first formula for Fourier, formula is for the obtaining Fourier cosine transform from the function f of x, and the second formula for the inverse Fourier cosine transform. That means we are obtaining f of x starting from f at c. Full screen them opening. Pen. අවුරුදු දෙනෙක් කවදද කියන්නද? 14 නේ බ්ලොක් ලීව් එක හම්බෙන්නේ. අයි ඒ සතියේ එන නිමෝඩු තෝගයක් තියෙනවා නේද සමහරට බ්ලොක් ලීව් දෙයි. ඊට පස්සේ මහසිකරද ඒකත් නිමාඩුනේ. ඒක නිසා සමහරට බ්ලොක් ලීව් එකක් දෙයි. බ්ලොක් ලීව් එකක් දුන්නොත් මම ඔයාලට දෙන්නම් මේ නෑ එහෙම නෙමෙයි. පැයක ටෙස්ට් එකක් දෙන්නම්. සතියක් ඕපන් කරලා තියන්නම්. කැමති වෙලාවක ලොග් කරලා ලියන්න LMS එකේ. MCQ ටෙස්ට් එක. හැබැයි කොපි කරන්න නම් බෑ ළමයි. කොපි කරන්න බැරි වෙන තමයි දෙන්නේ. බ්ලොක් ලීව් එකක් දුන්නොත් විතරයි දෙන්නේ. මොකද මට නිදාලා තියෙන පේපර් ඒක හදන්න. MCQ ටෙස්ට් එකක් එහෙම හදනවා කියන්නේ පැය දෙකක් තුනක් යන වැඩ. මිඩ් එක නම් එහෙම දෙන්නේ නැහැ. මිඩ් එක නම් එහෙම දෙන්නේ. මිඩ් එක ලේසි ළමයි. අර මම කිව්ව ගණන් ටික බලාගෙන එන්න එච්චරයි වෙන්න ඕනේ. හරිනේ මේක ලියාගෙන ඉවරනේ. මෙයාව මේ කවුද මේ රවීෂව ගෙනල්ලා අපේ 39 ළමයික ඉඳවල එක දවසක් තියන්න ඕනේ. එතකොට ඇවිල්ලා කියයිනේ විස්තර. රවීෂ තමයි හරියන්නේ. නංගි වෙනුවට වගේ යවන්න පුළුවන්. උගොල්ලෝ මේ නැලවෙන්න එනවනේ මෙතන. කොහොම පුළුවන් ද ඉගෙන ගන්න? ඔය ඇති වෙලාව. Okay. Similarly, the next thing that we are going to discuss is Fourier sine transform. Fourier sine transform. Here we use the notation. Don't write this thing. Here we use the notation at SW. So here this S4 here here this S is for sign. So we are using this S notation to represent sign. So we are going to obtain the expression for the Fourier sine transform as well as the inverse Fourier sine transform in the similar manner as the cosine transform. Here we use the notation f hat s w to represent Fourier sine transform, and the formula is similar with the earlier case. The only change is earlier case we consider f of x times cos x, and here cos wx. Here we are considering the sine, the term which consists of sine w. And most important thing is we are going to obtain this Fourier sine transform for even function, sorry, odd function. So if some function, as I mentioned earlier, there are some functions which satisfy, which does not satisfy the condition for odd or even. For those type of functions, we can find both of them. Actually, for those type of functions, we are going to deal with the Fourier as in the Fourier series. We have obtained the Fourier series for all kind of functions. But if a function satisfies the additional condition, if it is even, then we can proceed with Fourier cosine series. Or then we can proceed with Fourier sine series. Similarly, in the Fourier transform, we can find the Fourier transform for all kind of functions. But if it is even, then we can proceed with Fourier cosine. If it is odd, we can proceed with sine. Okay? We write this formula. So this first formula for obtaining the Fourier transform starting from the given function f of x. For the second function is obtaining the function f of x starting from f hat sw. So that means the first formula for obtaining the sine transform of f of x, and for the second one is for the obtaining inverse Fourier sine transform of f hat s. So obtaining this f hat s, which is starting from f of x, we call that process as Fourier sine transform technique. ඔයගලන්ට මොන හරි ඉන්ට්‍රෙස්ට් එකක් තියෙනවා නම් Fourier series එකෙන් කොහොමද Fourier integral එකට ආවේ කියලා මම කියන්න I have a note I can share. I have someone interested. Okay, back to class. So we have discussed the formulas for Fourier cosine and Fourier sine transform. So as I mentioned earlier, this notation F hat C W, we use this to represent Fourier cosine transform, and F hat SW, we use that notation to represent Fourier sine transform. So let's see, there is another notation that we are using for Fourier transform. Let's familiar with that notation as well. So we are using this letter capital F. This is not this capital F. We are writing this as something. It is a Greek symbol. This F to represent the Fourier transformation. So FC, it is for Fourier cosine transform, and Fs for Fourier sine transform, and we are writing this as FCF. That means the Fourier cosine transform of the function f. So this is equals to f hat c, and we are considering FSF, Fourier sine transform of the function f, and this is equals to f hat s. Similarly, we are using this notation F inverse C to represent inverse Fourier cosine transform, and F inverse S to represent inverse Fourier sine transform. Okay, so be familiar with these notations as well. Okay, now let's move to the example. This is the example. Please note down the example. Example number 1. The example that we are going to do as the first example. So you are asking to find the Fourier cosine and Fourier of the following function. The function is given as f of x is equals to, it is equals to k when x is varies from 0 to a, and it is equals to 0 when x is greater than a. So quickly note down this. Okay. මොකදනේ චක් ගානේ ලියා ගන්නකො. So first draw the graph of this function. Where the function f of x is given as it is equals to k if x is varies from 0 to a, and it is equals to 0. The function is equals to 0 when x greater than a. So this k is a constant. So draw the graph of this function f of x. So let's see the function. This is for the example number 1. The function f of x is given as, so it is equals to k if x is in between 0 and a, and it is equals to 0 when x greater than a. So if we have asking to plot the graph of this function, let's consider this is our x-axis and this is our f of x-axis. So from x is from 0 to a. X is from 0 to a, the function value is k. So let's see, this is a constant k. So This is the graph. And when x greater than a, the function value is 0. So from this point onward, the graph should be in this way. So this is the graph of the function. And what we have to do is, we are asking to find the Fourier cosine and Fourier sine transform of this function. So let's see to find So first we are going to find the Fourier cosine transform. So let's recall the expression f hat c w is equals to, tell me, square root of 2 over 5 integration from 0 to infinity f of x cosine wx dx. Okay, so here we have to consider the integration from 0 to infinity. That means we have to consider the values from 0 to infinity. So if we go back with this graph, when we are, this is the 0 and infinity is something in the, if we have go through with this x-axis so far, then we can reach the infinity. Then from 0, the integration from 0 to infinity. We are considering integration from 0 to infinity. Here in this example, it is provided as a piecewise function. The function is kodas dekata dila thiyena. So we can divide this integration from 0 to infinity into two pieces as from 0 to a plus a to infinity. Is it clear to everyone? ඇයි එහෙම කරන්න කියලා තේරෙනවද? මේ ෆන්ක්ෂන් එක දීලා තියෙන්නේ කොටස් දෙකක් විදියට. පළවෙනි පාර්ට් එක ඩිෆයින් කරලා තියෙන්නේ බිඳුවේ ඉඳන් a ට යනකල්. ඊතර පාර්ට් එක ඩිෆයින් කරලා තියෙන්නේ a ට වැඩි ඕනම විදියකට. So we can divide this integration into two pieces by starting from 0 to a as one piece and a to infinity as the other piece. So let's proceed with the integration. So we are going to find f hat c w. So we can keep this 2 over square root 2 over 5 as it is, and let's divide this integration into two pieces. From 0 to a, f of x cos wx dx plus a to infinity f of x cos wx dx. Okay, so if we consider the graph of this function, we can see that from a to 0 to a, what is the function? Teacher, इवरे तुम्हें सेट करो. So from 0 to a, what is the function? It is k. And from a to infinity, for the values higher than a, the function is defined as 0. So we can rewrite this expression by replacing those two functions. We can write it. This is equals to two over 5 from 0 to a k cos wx dx plus from a to infinity 0 cos wx dx. 0 times cos wx. 0 times cos wx. This entire thing provide 0. So if we integrate 0 with respect to any variable, that entire integration provide 0. So we can omit this part. So we are only consider the first part of this integration. So we can write an expression for the Fourier cosine series. So Fourier cosine transform of this function f of x as is equals to square root 2 over 5 integration from 0 to a k cos wx dx. Since this k is a constant, we can bring this k out. Square root 2 over 5 k from 0 to a cosine wx dx. This is a simple integration. So what is the integration of cos x? It is sin x. So if it is cos wx, it is 2 over 5k. If we integrate this, we will obtain sin wx over w. And since this is a definite integral, we need to substitute this upper and lower limit. We can write the expression the square root of 2 over 5k. So first we need to apply the upper limit. Sin aw over w minus lower limit sin 0 times w over w. Sin 0, since we know that sin 0 is equals to 0, so this part is 0. 0 over something, it again 0. So this part is equals to 0. So then we can obtain our answer as the Fourier cosine transform is equals to k over square root of 2 over 5 k over w sin a w. So then we can say that we have started from a function of variable x and we have obtained a function of variable w. So this is the Fourier cosine transform of the given function f. Okay, by applying the similar method, try to find the Fourier sine transform of this function. Okay, do the remaining part of the example. I am not asking you to talk with each other. Okay, so let's do Fourier sine transform of the function. Okay, tell me the expression. We have to consider square root of 2 over 5 integration from 0 to infinity f of x ko kata karana sin wx dx. So here also the function is defined as a piecewise function. Then we can divide this integration into two pieces according to the definition of the function. So we can write this is equals to square root of 2 over 5 from 0 to a f of x sin wx plus dx plus a to infinity f of x sin wx dx. Then for the first interval from 0 to a, the function is equals to k, and for the second interval the function is 0. 0 times sin 0 sin wx, this entire thing is 0. So if we integrate 0 with respect to any variable, this integration become 0. So then we can omit the second part of the integration. So we can write the expression for f hat is w is equals to from square root 2 over 5 integration from a to 0 k sin wx dx. Since this k is a constant, we can bring this k out. Square root of 2 over 5 k from 0 to a sin wx dx. Okay. Of sin wx. So it is minus cos wx over w. So we have to substitute lower and upper limit. So we can write, let's bring this w term out. So we can write square root 2 over 5 k over w. If we substitute x by a, it provides minus cos wa, and if we if we substitute x by 0, it provides minus cos 0. What is the value of cos 0? It is 1. Since it is minus cos 0, it should be minus 1. So then we will obtain an expression square root 2 over 5 k over w, minus times minus, it provides plus, then 1 minus cos wa as the Fourier sine transform of the given function f of x. Have you obtained this by yourself? Raise your hand if you have obtained this by yourself. Okay, very good. ටිකක් අමාරු ගානක් හදමු. Okay, write down this example. You are asking to find the Fourier cosine transform of e to the power minus x. How to read this expression? The expression which is represented by the symbol. What is the meaning of this expression? We are asking to find Fourier cosine transform. How do we identify it is cosine? Because this notation is C. Fourier cosine transform of the function f of x is equals to e to the power minus x. The meaning of this notation is this one. වෙනද? FC තියෙන්නේ. Okay, let's see. Example number 2. Example number 2, you are asking to find the Fourier cosine transform of e to the power minus x. So to find this one, Fourier cosine transform of e to the power minus x. Let's see, e to the power minus x. We have to proceed with the formula. Tell me the formula. Cosine transform e to the square root of 2 over 5 integration from 0 to infinity f of x cosine wx dx. Okay. So we can replace this f of x by to infinity e to the power minus x cosine wx dx. Okay, let's see the ability to solve the problems by using integration by parts. I'm not going to do this because I have explained how to apply the integration by parts earlier. You need to do this by yourself. Let's consider this integration separately. We are only considering e to the power minus x cos wx dx. මේක ටිකක් complicated හැබැයිනේ. කොහොමද හදු? කොටේ හැටි? ඔයා කොහොම අනිත් ළමයි කොහොම කටද කරන්නේ? ඔයා උගන්නපු ළමයින්ට දෙයියන්ගේ පිටයිනේ. ඔහොම බෑ හදන්න ඕන. මම නම් කියලා දෙන්නේ මම හදාගෙන යනවා ගාන. මම මගේ ළඟ උත්තරෙත් නෑ. මම හදාගෙන යනවා. ඕගොල්ලෝත් හදන්න දෙන්නේ. උගන්නන්න එක සැරයක් කියලා දුන්නාම ඇති ඒක දෙයක්. ඔයගොල්ලෝ නරක කරලා තියෙන්නේ කට්ටිය. This one is is equals to e to the power minus x over sin w x minus integration මෙතන මගේ performance පෙන්වන එක නෙවෙයි තියෙන්නේ ඔයගොල්ලෝ ගහන හදන්න මං දිහා බලන් ඉන්න එපා. ඔයගොල්ලෝ බලන් ඉන්න දෙයක් නැහැ මේ ඔයගොල්ලෝ හදන්න ඕනේ ගණන් මෙව්වා. This one.
equals to minus cos wx to the power minus x j by minus cos wx e to the power minus x plus 1 over w minus e to the power minus x sin wx minus 1 over w
කොතන හරි වැරදිලා තියෙනව නේද? මොකද තව ටික? කොතනද? තව දුරටද? කොතනද? ගුණ වෙන්න ඕනේ. ප්‍රශ්නයක් නෑ. මෙතන සෝරි මෙතන ගුණ වෙන්න ඕනේ නේ. Thank you. ඉතින් හදාගෙන යන්න වෙනවා. එතකොට මෙතන W වෙනවා. මෙතන මයිනස් වෙනවා නේද එතකොට? මෙතන උලින හදන්න නේද? මොකද්ද ගාන? බෑ මේක හදන්න ඕනේ මේක එක්සෑම් එකට දෙන්න තියෙන මේක අනිවාර්යෙන් හදන්න ඕනේ කියන්නේ. බෑ මේක හදන්න ඕනේ. අනිත් පැත්තට අරන් හදන්න කියන්නේ කොස් අර විදිහට අරගෙනද? අයගෙන්. कितना करना था? තියෙන ලේසිම ගාන එක්සෑම් එකට දෙන්න තියෙන්නේ මේක තමයි දෙන්න තියෙන්නේ. ඔව්. මේ ඔයාලට මේ ෆෝරියර් කොසයින් වලින් හරි සයින් වලින් හරි දෙන එක ලේසි ෆෝරියර් ට්‍රාන්ස්ෆෝම් දෙනවට වඩා. ඒ කියන්නේ මේක තමයි එක්සෑම් එකට දෙන්න තියෙන ලේසිම ගාන. ඊළඟට හදන්න තියෙන ඒවා ගැන හිතා ගන්නකො එතකොට. මේක ඉංජිනේරින් ළමයින්ගේ එක්සැම්පල් නම්බර් 1. ඉතින් ඔයාලට මම මෙතනින් එහාට කරන්නේ නැහැ. ඒක නිසා මේක ඔයාලට තියෙන ලෙක්සිම ගන්න. හරි මේක හදමු මේක හදමු. We need to evaluate this integral, this one. Let's consider this separately by as I. මේ පරිදිම පෙරන්නේ මේ ලියන කාටි. I is equals to integration from e to the power minus x cos wx dx. මතරස් කියන්නේ cos වලින් අරන් හදන එක ලේසි කියලාද? Let's keep e to the power minus x d over dx sin wx over w dx. Then we can write this as e to the power minus x sin wx over w minus sin wx 1 over w times e to the power minus x minus 1 dx. This is equals to e to the power minus x sin wx over w minus and minus plus 1 over w integration of e to the power minus x sin wx dx. So let's label this as, earlier I used I, no? So we are starting labeling this as j. I will use a separate color. This is j. So our j is equals to integration e to the power minus x sin wx dx. So we can rewrite this as e to the power minus x d over dx minus cos wx over w dx e to the power minus x minus cos wx over w minus, let's bring this minus out, then it becomes plus and 1 over w cos wx times e to the power minus x minus 1 dx. So you will obtain minus e to the power minus x cos wx over w minus 1 over w integration from cos wx e to the power minus x dx. This is our I. This is our I. So we will have obtained an expression for j is equals to minus e to the power minus x cos wx minus 1 over w I. So what we need to do is we need to find an expression for I. So we can replace this j by this one. So j is equals to e to the power minus x minus e to the power minus expression I is equals to e to the power minus x sin wx over w sin wx over w 1 over w plus 1 over w times j. So we can replace this j by minus e to the power minus x over w cos wx minus 1 over wi. So then we can write this as e to the power minus x sin wx over w, and then this will provide minus 1 over w squared e to the power minus x cos wx minus 1 over w to the power 2i. We bring this into that side, I times 1 plus 1 over w squared. වැරදිලා තියෙනවා කොතන හරි. හරිද මේ? No, හරියද? Is equals to 1 over w squared. If we consider this as common, e to the power minus x w sin wx minus cos wx. We can write I is equals to w squared plus 1 over, it's not equal, I times w squared plus 1 over w squared. This is equals to e to the power minus x over w squared, w sin omega x, wx minus cos wx. So here we can see that this w squared is common in both sides, so we can cancel those two, and then we will obtain an expression for I is equals to 1 over 1 plus w squared e to the power minus x times w sin wx minus cosine wx. So this is the answer that we have obtained for the integration. The I that we have considered, I is e to the power minus x cosine wx dx. But in our example, what we need to find is, we need to find the integration e to the power minus x cos wx dx from 0 to infinity. So that means we need to consider to the power minus x times w sin wx minus cos wx. And we need to apply the upper and lower limit. So when we apply this upper limit, infinity, e to the power minus infinity. I ඔයගොල්ලෝ දන්නේ නැනේ. Okay, remember that ඔයගොල්ලෝ මේ exponential graph ඇඳලා තියෙනවද? Exponential කියන්නේ මොකක්ද දන්නේ නැද්ද? So if we consider graph of e to the power minus x, it is just like That means when x goes to infinity, the value of e to the power minus x raised to 0. So this is something that you have to remember when we are considering the function e to the power minus x. When x raised to infinity, e to the power minus x goes to 0. So if we apply this upper limit here, e to the power minus infinity, it is goes to 0. So if we apply the upper limit, we just write it here. If we apply the upper limit, we will obtain the value as 0, then minus, then let's apply the lower limit. Lower limit is something you are familiar with. E to the power 0, e to the power minus 0, it is 1. W sine W times 0, sine 0, 0, cos W 0, cos 0 is 1. So you will obtain the next part as 1 over 1 plus W squared e to the power 0 minus 0 times cos lemene sine neda tibune sine W sine W. W sine W0 minus cos W0. And this is 1, this is 0, this is again 1. So you will obtain the answer as here minus times minus is equals to plus. So it provides 1 over 1 plus W squared. Yeah. This is 0, this is 1, this is 0, this is 1. So this is the answer. So we will obtain this for from 0 to infinity e to the power minus x cos wx dx. But the expression for the Fourier cosine transform is, let's see, Fourier cosine transform of f is equals to square root of 2 over 5 integration from 0 to infinity f of x cos wx dx. So we will have obtained the answer for this part, and to obtain the original problem Fourier cosine transform of e to the power minus x, this is equals to square root of 2 over 5 times the answer for this one. The answer is 1 over 1 plus omega square. That's all. I am happy. ගණන් දෙකක් හරි හදා ගන්න පුළුවන් මම හිතුවේ මෙච්චර කරගන්න පුළුවන් මේක. Okay, so for the next class, linearity. Okay, you will have your mid-semester examination on next week, so be prepared for the exam, and then we will meet again at next week. Okay, let's stop.